A random sample of graduates found that 15 are unemployed out of a sample of 120. Calculate an approximate 90% confidence interval to 4 decimal places for the proportion of all graduates who fail to find a job. Interpret your results. Okay, so first thing we're going to do, because I never remember the Z-scores. You should definitely remember them because in your exams, I would bet money on it that they're going to try and screw you with that. But I'm going to go distribution, normal, inverse normal. We're going to go central. The area is going to be 0.9. I'm going to set my standard deviation to 1 and my mean to 0, and that's going to give me the Z-score at 90% confidence. So for me, the Z-score is equal to 1.64. Now, I've seen in the exam that they're using 1.65. I don't know why they're doing that, but that's wrong on their part, not your part. They're wrong. So let's get started. The formula for this, for calculating the confidence interval, is the sample proportion plus minus. Now, they've written it in two separate ones, but it's the same thing. Plus minus the probability, 1 minus that probability, all over your number in the sample, and that will give you your confidence interval. Okay, so let's just chug and plug. So first thing I need to find is the sample proportion, which is going to be the 15 successes out of the 120 trials, which is going to give me 0.125. So I'm just going to plug that in here and get my confidence interval. 0.125 plus or minus our Z-score of 1.64 multiplied by 0.125 times 1 minus 0.125 all over 120, and that's going to give me my confidence interval. So I'm going to punch this in the first time with a plus, and then I'm just going to go back and change it to a minus. So 0.125 plus 1.64 square root, put my fraction in, 0.125 bracket 1 minus 0.125 bracket all over 120, execute. So the first number I've got in my confidence interval is that'll be the second one because it's the plus, 0.1745. Okay, and then I'm going to go back up and change that to a minus. Okay, and that'll give me my first one, 0.07549. Now, it's asked you to interpret the result, so it wants you to state your findings. So, therefore, we can be 90% confident that between 7.5 to 17.5% of graduates are unemployed. Okay, and there's my little statement. Okay, determine the sample size required to achieve a margin of error of 2% for the approximate 90% confidence interval. So this isn't going to change. This doesn't change. We're finding n, but that stays the same here, here, here. It tells us here that we're looking for the approximate 90% confidence interval, which means that my Z-score is not going to change. We don't know what the n is, and it's telling me that my confidence interval is going to be 2% each way of the mean. That's what the margin of error stands for. So what we're really going to do is we're just going to let this highlighted section equal the margin of error. Okay, and then that way we're going to find out how many people we need in our sample. So I'm going to chuck that in the calculator using solve n. So this is what I'm going to put in. 0.02 is equal to 1.64, 0.125, 1 minus 0.125, all over x, comma, x. Like I said before, you can get away with not doing this in some cases, but sometimes it will just really try to screw you. Okay, so 0.02 shift equals 1.64 square root fraction 0.125 comma 1 minus 0.125, close that bracket, all over our bad boy x, off to the side, comma, nope, it's still trying to take the square root, so press across, comma, x, close that bracket, get your answer. Whoop, we don't love that. There we go. Is equal to 735.4375 to 4 decimal places, or a sample of, now is it going to be 735 or 734? Let's think this through. We want to achieve a margin of error of 2%. So that means we need to round up. Otherwise, we just won't have enough. We won't make that margin of error. So 736, what are they? Graduates are required for a confidence, for an error of 2% at 90% confidence. Okay, and that's it.